In this segment, we'll talk about some of the benefits of utilizing the curve editor and dope sheet in Nuke. Here we have the script of a shot that has already had the first version of it reviewed, and now it has come back with some notes on it. Before we begin addressing any notes, let's walk through the script to get a sense of what is going on in the script. First, let's play the render to see what we're working with. Starting at the top, we have our source plate. Just by looking at the read node, these color bars at the bottom of the node tell me there are more than the standard RGBA layers contained in this source. So let's see what other information we have to work with. Going to the top left of the viewer, we can click on the layer drop-down menu and see what other layers there are. In this plate, an alpha layer, a depth layer, and 2 matte layers. I'm referring to these as layers because each of them can contain additional channels. When working with CG elements or CG animations such as this, it's highly beneficial to include all relevant and maybe even some irrelevant utility passes or AOVs from the 3D department in a single multi-channel EXR. If the 3D department includes these extra channels, then Nuke can save a lot of round trip and 3D re-render time because these extra channels allow the compositor to leverage that 3D information inside of Nuke. So if we take a look at the next node in the tree, we can already see that the matte channels are being put to use, as we are combining the red matte and the green matte channels to create a new alpha channel that didn't exist before. The new alpha channel becomes relevant when we view through the InPaint node. We can see the crab alpha was used to inpaint the information behind the crab for a clean plate of the background seaweed. The clean plate may not look ideal as it is, but we're going to be able to get away with it because it's an organic element and it'll be defocused. Again, another situation where we were able to save time doing the work in Nuke rather than sending a request to the 3D department to render a separate seaweed plate. Now that we have our background seaweed plate, we're going to put it on a card because we want to put this shot in 3D space. Putting the shot in 3D space is going to allow us more flexibility when it comes to adding in additional elements, or when working with actual camera information from the 3D department. Through a simple projection setup in Nuke's 3D space, we will be able to place these plates of seagrass. We can even add effects in Nuke to make the seagrass appear to move. In this example, an iDistort node is being driven by a UV color information generated by a simple noise node with animated values. The foreground seagrass has an additional transform node to give it a little extra sway. Moving on to the crab element, we can see that we're still using the alpha we generated earlier to pre-multiply the crab from the background seaweed. Good thing the 3D department included those extra passes. Now we don't have to ask them to render out a crab element. Last but not least, we have a couple of different renders of animated bubbles we are adding to the environment. Now that we've checked out all the elements we are working with in the script, let's see how it all comes together. If we view through the scene node, we can see how all the elements are laid out in 3D space. Since the elements were placed on a card, we can now move them around to any position we like. For instance, we can take the card of these bubbles, move them so they appear behind the crab. A simple 3D setup such as this in Nuke can save you the hassle of going back and forth with the 3D department and allow quicker turnarounds for revisions. A more in-depth look at the 3D functionality in Nuke will be discussed in the following segment. Now that we're familiar with our script, we can begin to address some of the notes. Because the script is so nicely organized with labeled backdrops, we can easily jump to any of them by pressing the J key and selecting the backdrop that we want to jump to. So let's select the shot node backdrop 04062 version 1. Looking at our first note, the foreground seagrass is swaying too much and we need to reduce the sway by 50%. So let's jump to the foreground seagrass. Take notice of the little red A in the top right corner of the nodes. The A indicates that there are animated values on that particular node. Let's open the Transform Node Properties panel. Here we can see the rotation has been animated. Rather than going to each of these keyframes and reducing the value 50%, we're going to change all of them at once through the curve editor. Before we jump into the curve editor, let's change our workspace to animation. To actually see what the current animation looks like, let's view through the crop node and adjust the viewer gain to see it a little bit better. Below the viewer are the curve editor and dope sheet. I modified the animation workspace by adding the dope sheet next to the curve editor. We can see the actual curve of the animation in the curve editor, as well as the keyframes where those values are keyed in the dope sheet. To reduce the sway by 50%, select the entire curve, Then just below the curve graph, we are going to divide the values of the curve in half by adding a /2 to the equation, or divided by 2 to the equation. You'll see that the values are now 50% of what they originally were. You could also use multiplication by taking the curve and multiplying it by a decimal percentage. Say if we wanted 50%, make it 0.5, then you would get the same results. All of the original values have now been reduced with simple math. Talk about a time saver. In addition to adjusting the curve with math expressions, there are also a number of curve presets to choose from in the contextual right-click menu. Unfortunately, there's not enough time in this segment to go through all of them, but I encourage you to explore them on your own. Should you need to customize the curve, you can do so in a number of ways, such as selecting multiple points and adjusting the transform box around the points. Adjusting the transform box will allow you to compress or expand the animation curve while maintaining the relationship between the selected points. Single point adjustments can be made to the curve by moving the point itself, the point handles, or by creating a new point when pressing Ctrl, Alt, and clicking on the left mouse button. You have complete control over the animation curve. Now let's address the next note on this list. The camera push is a little slow. Have the camera push finish at frame 150 and reverse the direction to pull out starting on the first frame. Let's jump over to the camera and open the Properties panel. You'll notice that the camera didn't actually have a backdrop to it, but I was still able to jump to it. That's because anytime you add a backdrop, it's automatically bookmarked. So if you want to be able to jump to specific nodes that don't have backdrops, just go ahead and bookmark those nodes. In the curve editor, values for the camera and for the transform we adjusted previously are being displayed. This is because the curve editor will display any node with animated values that is currently open in the Properties panel. To avoid any confusion, let's close the transform node properties. Now we can focus on the translate Z values for the camera. First, let's move the last keyframe from the end to frame 150. This can be done through the curve editor, but let's do it through the dope sheet for more accuracy to ensure the animation curve is not changed in any way. Now let's reverse the animation curve by selecting all the points on the curve, right-clicking, and choosing Predefined and Reverse. The animation curve is now reversed. If you need the animation to start on the first frame, you can either drag the curve to the first frame or input the number of frames you want to move the curve in the dope sheet. Since the reversed animation starts 30 frames in, we would enter 30 in this box, and making sure the keyframes are selected, press the Move button to start the animation where you desire. 2 notes down, 2 to go. Let's see what else is left to do. Now we have to do something about the bubble density. Let's take a look at those. View the bubbles at the crop nodes, double-clicking each of the bubble read nodes. Other than being able to adjust individual keyframes in the dope sheet, we can also adjust clip properties as well. We can change the frame range of the clip, change the offset where the clip will be visible, and we can change the starting point of the clip as well. Rather than having all the bubbles visible at once, let's shorten the clip range by dragging from the edges. This way it'll appear as a brief burst of bubbles. We can move the clip to wherever we want the bubbles to be visible, but for now we'll just leave it where it's at. One other thing we need to do before calling this node done is change the drop-down from hold to black, so that way static bubbles won't appear on screen before the clip animation actually starts. Now we can address our final note. For this one, let's view the bottom of our tree. A Z defocus is already in place, but we'll need to adjust the focus of it. The depth information for the Z defocus was already generated for us through the scanline render node, because we are getting our depth information from all of the cards that were placed in ZDepth. Because the crab on the card is just a flat crab, additional depth information for the crab was pulled from the original plate that came from the 3D department. The crab depth was then merged into the scene depth, giving us a much more accurate representation of the depth within the crab layer. Let's go to the first frame. When the Z defocus properties window is open, let's move the viewer focal point to the crab's screen left eye. Set a keyframe for this value, then jump to the end of the shot. Because of the camera move, we need to move the focal point to the crab's screen left eye again. And voila, we have addressed all of the notes, and we are now ready to send it back in for review. Before we move on to the next segment, I want to show another example of how Nuke can be utilized for animation using live action elements. In this example, we're using live action footage and adding 2D animation over it. Let's take a look at the render of the latest revision. Depending on the style you're going for, the 2D animation can be used for final or as a previs of elements to come. We can use the previs animation to swap out the 2D animation with VFX elements when they become available. Coming up in the next segment, you want to stay tuned because we'll be going over 3D projections and more about the 3D space within inside of Nuke.